Hello, my lovely and wonderful humans. This is Miss Reyes coming at you live from home. I'm not live, actually. This is probably tomorrow that you're watching it. But yeah, I'm sick. So I still wanted to make sure that you guys could get your work done. So I'm recording this video for you today. It's a little bit harder. So yeah, you're definitely going to need some help. Okay. So as I am recording this from home, you're probably going to hear me like coughing and sneezing and probably my dog and almost definitely my cat, King Triton. I'm sure he'll pop up here soon. So if you see him, say hi. Just, it's working from home, All right. Anyways, so we are talking about how energy is used in organisms, right? So you are an organism. Our lions are organisms, right? We're all organisms. We're living, we're breathing, and we require the use of energy. How do we get that energy? How do you get that energy? You got to eat stuff, right? And the stuff that you eat can basically be broken down to like the tiniest bits. And I guess it's not the tiniest bits, but for our intensive purposes in this, we break them down into carbohydrates, fats, and protein. So these are going to be three very, very important organic molecules that we consume and get our energy from. So just keep them in mind. So let's talk about model A. So model A here, we have organism A and we have organism B. So I'm going to go through organism A with you guys and maybe answer a couple questions down here. But let's go through organism A together, and then you guys should be going through organism B. As I complete organism A, make sure you pause the video and complete organism B, okay? Because in order to complete this entire assignment, you are going to have to complete the other stuff. So you're going to be requiring both pieces of information to figure it out, okay? So anyways, let's get to organism A. So if we look over here, I see amount ingested, okay? And we're talking about organism A, so we're looking over here at this picture. And as we're looking at this picture, we're noticing some things. So here's our organism, it's just in this box, right? So it's going to be some random, doesn't matter kind of organism. But we also have some arrows, right? And pay really good attention to where they're pointing to, because it is basically going to tell you the way that energy is moving. So when you eat, right? When you eat, your energy is going to come from outside and it's going to go in your mouth and into your belly, right? And then it's going to leave you in certain ways. This is King Triton, guys. Let me get rid of him. Sorry about that, y'all. Like I said, you were definitely going to meet him. And he's probably going to be back. But anyways, so I was talking about the arrows. So our arrows are going to basically show us which way energy is moving. And like I said, you got energy out here. So like a hamburger, right? If this organism A was you, we got a hamburger over here. It's going into our mouths and our bellies, and then it's going to leave how? Think about it. I don't want to give you the answer, but I'm sure you guys know how that hamburger leaves your body. But there are going to be a couple of ways here. So pay attention to this. Also take note in these labels. So we got grass ingested. So ingested means eaten, right? We're consuming it, it's going in our mouths. And then egested. So one of these questions is, what is egested waste? I want you guys to figure that out. I don't think it's too hard. But anyways, if we look over here, our amount ingested sounds a lot like grass ingested, right? For organism A at least. So we can literally just carry down this number. So 58. All right. And that should be kilograms because it says it right here. So 58 kilograms. Our next one is amount needed to maintain biomass. So let's look back up at our picture. And over here we see the amount that is needed to maintain biomass per day, which is 9.5 kilograms. So I'm going to once again carry that number down here and mark it with a kilogram. All right, next thing over here, we've got amount egested. So again, you guys got to figure out what egested means, but over here is the egested waste per day, which is 23.8. So again, I'm going to carry down my number. Okay, but Miss Reyes, that's all of the labels and numbers that we have. And we still have one box over here. You can tell how lonely I'm getting, guys, because like, I'm like talking to myself. Anyways, so let's figure out what the calculation for what's missing. And we actually have a space down here to do that, to like actually write out our work. So it's always a really great idea to write out your work. So that way your teacher can look at that work and see if something went wrong. If maybe you used the wrong number, or maybe if something just got mixed around, right? So always write out what your work is, okay? And I'm just gonna split this down the page so that I have enough room for both organisms when I'm going through it. Okay, and how am I going to calculate that what's missing? So we're talking about what's ingested, so what's going in, and then we're talking about what's needed to maintain biomass and what's egested. So these things are going to be things that are going to be gotten rid of, right? We've got 2 arrows over here and 1 arrow that's going in. 2 arrows going out, 1 arrow going in. So if I say that, what do you think we're going to have to do? Yeah, we're going to have to subtract the amount that we've ingested, which, as you can see right here, is 58. Okay, and I'm not going to carry the labels because I know all my labels are going to be kilograms. So we've ingested 58 kilograms, and I have lost 9.5 kilograms, as well as 23.8 kilograms, right? Okay, so remember, we have to add these 2 losses because we're subtracting what we've gained from what we've lost. And so you must add these 2 together because these 2 numbers represent what is lost. So in order to find out what's missing, we have to figure out what is lost here. So we can subtract those numbers and you should get 24.7. And now we can bring our label down, which is kilograms, okay? And that's going to carry right up. So 24.7 kilograms. Okay. So this is where you should be pausing that video and going back to finish organism B. So get these 2 done here. All right. Show your work. Use the same formula and processes that I used. Okay. So pause the video. All right. Now we're back. So had to take a little cough break there. Sorry, y'all. Okay. So let's move on to question number 4. What else do the organisms do with the food that they ingest besides maintaining biomass and waste production? So think about it, like you're maintaining your biomass, right? So you want to continue to have a body, basically. You're trying to maintain your weight because we're animals out in the safari and it's hot and we're trying to catch our food, all that good stuff, right? But we're also going to produce some waste, so some poo, right? Everybody poos, don't worry about it, guys. So to basically sum all that up, we're going to say, here's like the scientific way to say it. This is going to be the energy for metabolic processes and that's an and here, energy storage. Okay, so there's some big words here. So let's break those down. So we got metabolic processes. So metabolic, think about metabolism, right? So when we're talking about metabolism, typically we're talking about how long it takes your body to consume what you eat. So that is basically what's going on here. We've got metabolic processes. Your body is consuming the food and there are processes that are happening. So that's that part. And then over here, we have energy storage. So what we know energy storage as is mostly like fat, right? So we use fat. And then when we're starving one day, maybe we don't have a good catch, we start eating that fat that's on our bodies to maintain energy. And that's energy storage. So Over here, we have 5 and 6, and it's asking what a carnivore, whether organism A or B is a carnivore or herbivore. So in order to figure those out, first let's talk about the definition. So a carnivore is going to be a meat eater, okay? So carnivores eat carne or meat, which carne is meat for Spanish. And then we have herbivores, okay? And herb, think like the herbs that you put like on a steak that you're grilling. And those are plants, right? So herbivores are going to eat only plants. So as you're looking at that, pay attention to our labels, right? Our labels are important. And then also pay attention to like the amounts that these guys are eating. Do you think you're going to eat a 58 kilogram steak? Or do you think you're going to eat a 6.2 kilogram steak? Oh, that would be huge. That would be a ton. Like, boys, I know y'all are like, Miss Reyes, I could totally eat a steak that big. No, honey, no, you couldn't. Okay, just trust me. All right. So let's move on to page number 2. Okay, so we are back to page number 2. So here we have model B. So forget about model A. We figured that one out already. But if we go to our first question here, in model B, what are the 3 ways energy is used by the organisms? So let's take a look at those arrows, right? Because we talked about this is what's going into the organism, which in this case is an elephant. And these arrows that are pointing out from the elephant are going to be ways that that energy is used. So do you think we're going to be paying attention to what's going in or what's going out, right? Is used by, right? So we are going to be looking at these 3 things here. And what are they labeled? Respiration. That's our first one. Respiration. Respiration. So respiration is just like a big fancy scientific way of saying breathing. Okay, which I'm struggling to do right now. Anyways, so what's our next label over here? We have heat loss. That is our second one, indeed, heat loss. Okay. What's heat loss though? Like, think about it. If you're out in the hot weather, how does your body react? It tries to cool itself down, right? So it's going to start sweating. And do you think that sweating requires energy? Absolutely it does. So we're going to have some heat loss. But also, if you're like in the cold tundra, right? You're penguin, you're going to lose heat to that cold. So in order to conserve that heat, your body's going to react. Like, that's where you get like goosebumps and stuff, right? Your body's trying to warm itself up. So your body has processes to mitigate or to hopefully reduce that heat loss, but we're still losing heat regardless. But anyways, if we look to our third and last label here, we have egested waste per day. Okay, so again, egested waste. All right. And there is a simpler way of saying that, but like I said, I want you guys to figure out what that egested means. So go ahead and write that part in. You guys do that. That's you. So pause the video and write that in, okay? I think you know. All right, moving on here. Okay, so we are on a table that was similar to model A. And we're basically going to be doing the same thing, right? We've got some labels over here, and it looks like they match the labels that are in our diagram over here. So our first one is food ingested. So if I'm looking, oh, here's ingested. So we can carry that number down, which is 48,384. And then kilograms, right? Sorry, guys. Okay, the second label down here is egested waste, right? So let's take a look at these guys over here. Here we have egested waste. So this number we're going to carry down here, which is 19,837 kcal. Okay, forget the labels, y'all. Oh, King Triton. Guys, he just tried to sabotage everything. Sorry. Okay, so moving on. Okay, forget the labels, guys. We're talking about kcals and Miss Reyes messed up. I'm not recording this again. Okay, so the third thing we have here is respiration. So we've used grass ingested, we've used ingested waste. Here we have respiration, which is 11,612. So let's just carry that number down, 612. Okay, and then we've got our last thing down here, which is heat loss. Okay, and luckily they have calculated that for us. So we can carry that number down as well, which is going to be 14,031 kcals. Okay. All right. So moving on here to question number 9. Does the amount of energy from the food eaten, or kcals, by each organism equal the amount of energy used by each organism? So we're talking about each organism, right? So we should probably split this up again. So let's do elephant over here, and we're going to do lion over here. So once again, I am going to split my page because I'm going to show my work. So that way, if I get something wrong, at least Miss Reyes can figure out what happened. So for our elephant, again, we are talking about the amount of energy from the food eaten. So what's that number going to be? The food eaten, right? So that number. By each organism equal the amount of energy that is used. So what is being used here? Remember I talked about those arrows where the arrows indicate that the energy is moving out of the organism. So when it's moving out of the organism, we're using it, right? So we have 3 different arrows. So we are going to have to add 3 different numbers together. So those 3 different numbers are going to be egested waste, because we have waste, right? We have respiration because it literally requires energy just for you to breathe. And then we have that heat loss, which is your body just trying to make up for losing any kind of heat and energy. So we need to add those 3 things together. So let me write those numbers down here. 11,612 plus 1431. Okay, and then what does that equal? Should be, and since I'm running out of room here, I'm going to write it down here, but that number should come out to 45,480 calories. Okay, so that's not our final calculation, right? We need to compare the amount of energy from the food eaten to the amount of energy that is used by each organism. So does this number equal this number? No, it does not, right? So more math, yay. Okay, so we are going to take the bigger number and we're going to subtract the littler number from it. So 48,384 minus 45,480, and that's what came from down here, right? So when we calculate that out, and I'm going to have to once again step down here to write my answer, go ahead and type it in your phones. No worries, we got calculators there. It's going to be 2,904 kcals of difference, right? So that is energy that's just kind of, that's the difference between what is being ingested and what is being used. So where's that going? I don't know. Let's find out. Okay, so at this point in the video, you should definitely be pausing to complete the lion portion and the lion portion here. Okay, so pause the video. Alrighty, so on to page number 3. Okay, so question number 10, and again, we have these split organisms, so we're just going to do the elephant together. I'll let you do the lion. So here we are going to calculate the amount of potential energy that each organism does not use efficiently. We're going to support our answer by showing the calculations. Remember, always show calculations. So egested waste and heat loss are not an efficient use of energy. So here we're talking about our elephant. We are going to need to get those numbers back from over here. Okay. And we are going to have to put them in there. So let me figure out the best way to do that. To like show you guys. Okay. How about that? Okay, so here we've got our numbers from page number 2 that we just completed. And I need to figure out what the heat loss for the elephant was. So heat loss right here, that's my number. I need to carry that down. So that's 14,031. I'm going to add that to my egested waste. And again, I can carry this number down, egested waste, which is going to be 19,837. And then the last part that I need to carry down is the food ingested. And again, I look over here on my handy dandy thing that I just completed, and that is going to be the 48,384 number. Okay, we're going to take all of this because we want a percentage, right? We want a percentage. So we're going to take all of this and we have to multiply that by 100. Okay, and we want a percentage. So you guys should pause the video, do the calculations, and figure that out. Okay, you guys figure that out. You should be able to figure that out. Okay, I also recommend that you pause the video and finish out the line as well, since you already did those calculations, brought down the important information. So you should be able to do the line as well. Okay. And just talking about that number, that percentage, once again, is talking about the energy that each organism does not use efficiently. So they're literally losing all of that. That's going to be a big number, y'all. Like, that is a ton of energy to just lose efficient or not efficiently, right? So we're talking about efficiency. We're talking about things that matter. So that's being wasted on stuff that doesn't matter. Okay, but moving on to question number 11. The elephant and the lion do not have the same amount of efficiency when using energy. Which organism is more efficient, the elephant or the lion? Tell me which one, like circle it. Circle, is it the elephant or is it the lion? And I can't figure that out because I didn't do the calculations for the lion, but you guys did, right? So you're going to have to circle one, and then you're going to have to give me a reason which could account for the difference. Okay. So basically, to like sum all that up, what I'm asking you, and you don't have to write this down, I'm just writing it for you. But the question that I'm really asking you here is, who is wasting less? Who is wasting less? Okay. So answer that question. And then tell me why you think that might be happening. All right. Okay, let's go to question number 12. Question number 12 asks, using the information in model B as a reference, which of the following from the elephant is directly available to the lion? So is directly available to the lion. So what's the lion doing with the elephant? Think about it. What's the lion gonna do to the elephant? He's gonna eat him. Oh my goodness. Yeah, that lion is gonna eat the elephant. So what do you think that lion is actually gonna get out of it? Do you think that lion is gonna eat the grass? Nah. Do you think the lion is going to eat the breathing from the elephant? Nah. Do you think it's gonna eat its poopy or urine? Nah. I hope not. Oh, that would be weird. So that leaves only one, and that is biomass. And biomass, if we split it apart, right? Mass is a measurement of weight, right? And then bio, which is life. So the weight of life, right? So it's basically the meat of the animal. Okay. So on to question 13, the last and final question. I know you guys made it. Oh, so close. Okay, so what percentage of the elephant's grass energy is available for the lion? We're going to support our answer by showing calculations. Super important, always show your calculations, guys. Have I not drilled it enough yet? Show your calculations. So in the formula below, we're going to use the total kcal used, and we're going to figure that out by calculating, adding together respiration plus egested waste and heat loss. And wait a second there. I think I already did that, right? Oh, look at that. I already figured that out. I already added those three numbers together, right? So here's that number. That's going to get carried over here, but let's start at the beginning. So here we have total kcal ingested. And again, we're talking about the elephant's grass energy, right? So we're looking at the elephant's information over here. So our elephant's information for what was ingested is going to be that 48,384 number. Okay. And then if we're following the formula, we're going to subtract that number, or we're going to subtract the total kcal used, which again, we already figured that out, right? Because we added all three of those lost pieces together. And we came up with that 2,904 number. Okay, so that is going to be put over the total kcal ingested, which is the same number as this one. So I can literally just copy that down. So 384. Okay, and then once again, I need a percentage. So I need to take this whole calculation and then I need to multiply it by 100. So this is basically like a 3-step calculation. Okay, so first of all, you're going to start off subtracting 2,904 from 48,000. Then you're going to take whatever number that is and you're going to divide it by this number. Then you're going to multiply it by 100. So it's a 3-step calculator process. Okay, please feel free to use it. Please feel free to use your calculator. Okay. And like I said, you're going to come out with a percentage. Okay. That number is going to be very interesting. And I want you guys to think about that, about the energy that you are actually getting out of that. Because like we said, all these things make up the elephant, right? The weight of the elephant. All of those things make it up. But think about how much we're actually getting when we eat the elephant. It's only that one thing out of all of these. So yeah, really pay attention to that number when you calculate it, okay? All righty, guys, that is everything. I miss you all a lot. I can't wait to be back. But take care, be safe, be nice to Mrs. Kinsey and Keith, of course. And I will see you as soon as I possibly can. All right, have a great day, guys. Bye.